In this episode, we're going to review common causes of broken SSH sessions when connecting from home, coffee shops, or hotels. It can be very annoying to be working on something, going to grab a coffee, and then coming back to a dropped or frozen SSH connection. Let me give you a little demo of what a broken SSH session actually looks like. Say for example that we SSH into a remote machine from home. We're happily working away on something, get distracted with something else, and let the SSH connection idle for about 10 minutes. Then when we return, there is a write failed broken pipe error message, and our SSH session has been disconnected. It is also common to have this session just hang or freeze after letting it sit idle for a while, and the connection will eventually time out and terminate. This is a problem that's very annoying, and it has personally bitten me along with several colleagues. Using something like Screen can make this less painful, but you still have to reconnect many times. So I thought it might be useful to share my thoughts on the topic and look at ways to solve this problem. There is an OpenSSH FAQ page that sheds some light on the issue. You can find this page linked in the episode notes below. I wanted to briefly chat about this page and then we can look at it in detail via some diagrams. So the question is, my SSH connection freezes or drops out after n minutes of inactivity. The answer says that this is usually a result of packet filtering or a NAT device timing out TCP connections due to inactivity. Then that there are a couple of SSH client and server configuration settings that you can use to tune this, namely server alive interval and client alive interval. The answer goes on to say that using these settings will ensure that the connection is kept fresh in a packet filtering firewalls or NAT devices connection table. So what does this actually mean? Well, I thought I would throw together some diagrams to illustrate the problem and to show you what these SSH connection settings actually do. So let's say in our example setup, which actually mimics very closely my use case, we have an SSH client and several SSH servers. I typically connect to AWS, work, and school from home. I wanted to focus on the connection path between the SSH client and server, as this is typically the cause of dropped or frozen SSH connections. So what does a typical connection path look like when coming from home, a coffee shop, or a hotel? Well, we almost always connect through some type of NAT device, highlighted here in blue. This NAT device proxies our traffic and acts as a type of intermediary for us on the internet, as our connection eventually finds its way to the destination SSH server. I don't want to take too much time talking about the internal and external networks of a NAT device, but I've linked to the Wikipedia page for network address translation in the episode notes below. Okay, so now that we have a basic idea of how the packets flow, what does an example SSH connection look like? Well, let's say we wanted to connect out to AWS. As successful connections are established, the NAT device, these are your modern cable modems, Wi-Fi routers, and coffee shop access points which do network address translation. They will add connections to some type of NAT connection or session table, like so. Same goes for connections to work or school. The main cause of dropped or frozen SSH sessions are likely these NAT devices that almost all of us connect through when working remotely. For example, my home cable modem, which acts as a router, will drop idle connections after 5 minutes. In this example, let's say I'm actively working on the AWS and work SSH sessions, but I've left the school connection set idle for more than 5 minutes. Well, my NAT router is going to come through after 5 minutes of inactivity and close the connection by deleting it from the connection table. Why does this happen? Well, I've done plenty of reading on the topic over the last week, and it basically boils down to a couple things. One is that these home routers are cheap, and maintaining the connection table costs limited resources. The second answer is that it's just a software timeout to clean up what the router considers to be stale or hung connections. Think about what the connection table looks like on one of these routers at a popular coffee shop. There could be thousands or tens of thousands of active connections, so cleaning up stale connections is actually a really good idea. So what can we do about our idle SSH connections being killed? Well, let's quickly hop back to the OpenSSH FAQ page where it provides configuration suggestions for both SSH clients and SSH servers, along with links to their respective man pages. The SSH client man page provides this server alive interval setting along with an integer value, which allows you to send SSH no-op or null commands through the encrypted SSH channel on a set interval. This fools routers into thinking the session is alive even when idle. Let's hop over to the SSH server man page, as it provides the client alive interval setting along with an integer value. This works in the exact same way as the client setting, but these null packets are now sent from the server rather than the client. I thought it might make more sense to actually show you what these configuration settings do through the use of some animated diagrams, so let's go have a look. In this example, we've established a SSH connection from home to work. Let's add this client-side configuration setting called server alive interval with a value of 60. You can do this in the SSH global client config file located in /etc or on a user-by-user basis through their personal SSH configuration files located in each user's home directory. Once this setting is active, regardless of activity on your part, the SSH client will send no-op commands through the SSH tunnel, keeping activity flowing through the connection. The entire goal is to keep our SSH connection fresh in the router's connection table. On the flip side, you can add a client alive interval setting to the SSH server's configuration file. This does the exact same thing as the client configuration tweaks we just covered. Basically, regardless of activity on your part, the SSH server sends no-op commands through the encrypted SSH tunnel, keeping the SSH connections fresh in the router's eyes. You might be wondering, what are some of the pros and cons of having this on the client side versus the server side? Well, there is nothing stopping you from actually doing both. Personally, I like to do this on the client side as I typically initiate connections from the same place almost all of the time. Meaning that, no matter the SSH server I connect to, I know that the SSH session will not be dropped due to a router thinking it's an idle connection. This begs the question, in what instances would you want to do this on the server side? Well, most corporate networks, if they're running SSH on the internet, have some type of bastion host, or jump host, which funnels all SSH traffic through it. If you're running this type of server, then it would make sense to enable the client alive interval setting, as you will improve the user experience of many people who use your jump host, mainly from home or hotels while out on the road. By now you should know what the problem looks like, what causes it, and how to fix it. So let's see what these changes actually look like in the real world. This is actually going to be a bit anticlimactic after the build-up, as it's really simple. To add the client-side configuration tweaks, all you need to have is a file in your home directory under the .ssh directory called config. And as you can see, for all SSH hosts, we set a server alive interval of 60 seconds. You can really set this to any value that works for you, but 60 seconds seems to work well for me. If you had to create this file, then you should ensure that it has the correct permissions, and change the ownership too if needed. You can find these commands in the episode notes below. Okay, so that's the way to configure the client settings through the home directories, but you can also do this via the files located in etc SSH too. You can modify the global SSH client configuration through the SSH config file, or the server configuration through the SSHD config file. Let's modify the global client config first by opening it up in VI. My global client configuration file doesn't actually already have the value set, so I'm just going to add it along with the comment down at the bottom here. Let's fix the formatting too. Once we save this file, all users on the machine should see the benefit of this change. Although if they have existing connections, they will not see the update until they reconnect. So what about if this machine is an SSH server? Well, let's add the values to the SSHD config file. Again, my current configuration doesn't actually have this setting right now, so let's jump down to the bottom and add it here, along with a comment. Finally, let's restart the SSH server, or you could reload it too. This is a personal preference. So at this point, any new SSH connection into this server should have a client alive interval no-op command sent out every 60 seconds, keeping the SSH connection fresh. So that basically wraps up the command line part of this episode, but I thought I might take a minute to talk to the guys and gals out there using the extremely popular PuTTY and WinSCP utilities on Windows. I thought I would quickly show you how to change these settings too. I fired up a Windows virtual machine on AWS and installed PuTTY and WinSCP, so you can see what these configuration settings look like for yourself. Let's start with PuTTY. You can do this on a connection-by-connection basis, or add it to the default settings. To add the keep alive no-op command, go over to the connection category over on the left-hand side here. From here, you will see the section talking about sending null keep alive packets to the SSH server. Again, let's enter a value of 60 here. If you wish, you can also enable TCP keep alive packets. This works at the TCP level, where the SSH no-op command actually works inside our encrypted tunnel. So it's harder for something doing packet inspection to see what's actually going on. Having both enabled shouldn't hurt anything. Then let's go back to the sessions category and save our changes. Okay, so with PuTTY out of the way, let's go and jump over to WinSCP. Let's start by opening it up and having a look. If you've used this before, you might have saved sessions under here. To enable the keep alive packets, we have to go into the advanced menu here. Head over to the connection category on the left-hand side, then on the right-hand side you should see something about keep alive packets. Click the send null SSH packets radio button. Again, I like to send these packets every 60 seconds, but it's really up to you. My home router kills connections after 300 seconds, so I need to have something smaller than that. I figure 60 seconds should cover me at home, a coffee shop, or even a hotel. Finally, let's click OK and save our settings. So if you ever have a SSH session drop out, or freeze due to a rate failed broken pipe error message, this episode should likely help you solve that problem. It helped me fix the issue that I was having. Alright, that concludes this episode. Thanks for watching. If you would like to get notified about future episodes, please subscribe to my mailing list. You can do this by going to the Get Notified link in the header and entering your email address. Have questions, comments, or concerns about this episode? What about episode ideas? I'd love to hear your feedback, either good or bad. Shoot me an email, justin@sysadmincasts.com.